All right, so 10.1 is a rectangular coordinate system. If you just need to see that title, the title is right here, rectangular coordinate system. And let me go back. So we're starting off with the Cartesian coordinate plane. Basically, we're looking in the graphing. So your graph, your Cartesian coordinate plane is split up by our axes. You got the x-axis, which is your horizontal axis, your y-axis, which is your vertical axis, and we have our quadrants going counterclockwise: quadrant 1, quadrant 2, 3, and 4. To get into quadrant 1, you need to make 2 positive moves. Quadrant 2, a negative move, then a positive move. Quadrant 3, 2 negative moves. And then quadrant 4, positive move, then a negative move. So where these two axes intersect, that will be your origin, the coordinates of your origin, 0, 0. To the right of your origin is positive, to the left of your origin, negative values. Above your origin, positive, and below your origin, negative. All right. Make sure we're good before I scroll up. Oh, also, we're going to grab what we call ordered pairs. That's what we have right here. They call ordered pairs because the order matters. So you're talking about your horizontal move first, vertical move second. In other words, X goes first, then Y. So you can think about, walk to the elevator, go down, or you run and then jump, whichever way you want to think about it. But it's your horizontal move first, then your vertical move. All right, can I scroll up? Trying to erase this stuff so we can walk through it a little bit. All right. So when we look at 2, 5, we're just going to go ahead and graph a few points and make sure we're okay with graphing. When we look at 2, 5, you start at your origin, go to the right 2, and then up 5. So this would be 2, 5. And that puts us in quadrant 1. And we have 2 positive moves to the right 2 and up 5. You always start at your origin, go to the right 2 and up 5 in this case. Next one for -1, -3. Start at your origin once again, go to the left 1, down 3. That's -1, -3. And that puts us in quadrant 3. Next one, -4, 2. Start at your origin, go to the left 4, up 2. That puts us in quadrant 2. Then for that fourth point, start at your origin once again. And since it's +1, you go to the right 1. And then we go down 5 for that -5. So before we go to those next 2 points, any questions?
No.
All right, Thank you. Oh, I didn't put up here. This is quadrant 4. All right, so for the next 2 points, once again, you start at your origin. Now notice for 3, 0, you go to the right 3, that's your X move, but then you don't move up or down for Y at all because Y is 0. And that is on your X-axis. So it's not in the quadrant at all. It's on your X-axis. And then for 0, 3, you don't move left or right for X because of 0, and then you move up 3. That's 0, 3. So that's on your Y-axis. All right, questions? Any questions on those? All right. Solutions of an ordered pair. I said solutions of an ordered pair, solutions of an equation. Remember when we just had a regular equation, it was a state of value that made an equation true. So an ordered pair that is a solution for these equations, just an ordered pair that you can plug in that will make that equation true. So what they would do is give us an equation like this, give us an ordered pair, and ask us, is it a solution for this equation? You will plug it in accordingly and see if a true statement occurs. All right. All right, so you notice I already labeled, our first one. Always know your first value in that order pair is X, the second value is Y. So we plug in 1 right here for X, 2 right here for Y. 4 times 1 is 4, 3 times 2 is 6. So 4 minus 6 is -2, so -2 is equal to -2, that's true. So that means, yes, it is a solution for this equation. In other words,
real quick.
in other words, if you were to graph this line, 1, 2 would be on that graph.
Thank you.
Mm-hmm. All right, any questions on that? And so just making a statement right there, there are infinitely many solutions to a linear equation. So every point that's on the line, when we get to graphing, every point that's on that line is a solution to that equation. So like I said, this 1, 2 will be a point on the line that this is, that this generates. All right. So doing that one more time, this time we have y equal to 3x minus 5, and they give us 2 ordered pairs to try to see if they are solutions of that equation. So we have 2, 3 as one ordered pair. Then we have 3, 4 as the other ordered pair. All right. So on the left, I substituted in 2, 3. On the right, I substituted in 3, 4. So don't forget the first component of your ordered pair is always x. The second component of your ordered pair is always y. So for the first one, I plug in a 2 right here for x, 3 for y. And when we simplify it, 3 times 2 is 6. 6 minus 5 is 1. So they end up being 3 equal to 1. It's not true, so they ended up not being a solution for us. Then when I plug in 3, 4, 3 for x, 4 for y. 3 times 3 is 9. 9 minus 5 is 4. So that ended up being a solution. All right. Question on those two. All right. Going up. That's not 10-4. So there are two different ways, not two different ways, three different ways that we will graph our linear equations. So we have 3 methods here. We got slopes. Hold on. 10-1. Just making sure I got these. Look like it's 10-2. We'll do slopes. Yep, that's 10-2. All of that is in 10-2, looks like. I wonder why I did 3, 4, and 5. Okay. Okay. So 3 different ways that we're going to be looking at graphing our linear equations. First way is to create an XY chart. We're in 10-1 and 10-2. Discusses that. Next, we look at our intercepts, graphing using our intercepts. That's in 10-2. And then graphing using our slopes is also in 10-2. One second. The function notation. Surface area. Okay. Hold on, trying to make sure I don't leave anything out at the parachute. Yeah, okay, cool. All right. So let's go back to my notes. All right, so let's look at the first way. Creating an XY chart. Let me erase some of this stuff. All right, so let's say if we wanted to graph 2x plus 1. All right. Now, unless they give you the values, they could give you the values for x, or you have the option of just choosing yourself. If they just say graph, then you would choose them yourself. Notice I chose -1, 0, and 1. You don't have to use those values. You can use 1, 2, and 3 if you like. But basically, you choose those values. All right, for x. Just remember that whatever you choose, though, you have to graph it. So if you choose 150 and 1 million, just know you're going to have to graph that. So I chose -1, 0, and 1, and what I'll do is plug those in accordingly. Remember, that's our x. So we're looking at y is equal to 2x, so that means 2 times -1. plus 1. That's negative 2 plus 1, which is negative 1. So it just so happens that when x is negative 1, y is negative 1. Of course, that will not always be the case. Plug in 0. 2 times 0 is 0. 0 plus 1 is 1. So when x is 0, y is 1. Then we'll do the same thing for positive 1. Plug in 1, and we will get 3. So before we go any further, questions on what we did. Once again, you choose those x values. I'll show you in a second why it doesn't matter what x values you choose. As long as you calculate correctly, you'll still get the same line. All right. So then you go and graph those 3 points. So you start your origin, go to the left one, down one, which is right here. Start your origin for 0, 1. You don't move left or right because x is 0, but then go up 1. It's right here. Then go start your origin, go to the right one, up 3. And that's this value right here. Then you connect your dots and you get this line. So going back to what I was saying, how it doesn't matter what values you choose for x. If you were to choose 20, x equal to 20, that would be something way over here. Then that will give us a value. It would be something way over here. And that will give us a y value way over here that will still connect to this line right here. Same things if you chose negative 100, it'll be something that's way over there to the left, but it will give us a value that will still connect to this line down here. So it doesn't matter what value you choose. You just have to remember that whatever you choose, though, you will have to graph it. So you don't want to choose anything too ridiculous when you go about trying to graph your points. All right, questions. Hold up, is that okay? All right, let me erase this stuff. I'll put it back up in a second, but I just want to talk about it real quick. So when we look at what we have here, we have y equal to negative 3/5 x plus 2. So you want to choose something that you can plug in for x that will produce a solid number. You don't want to have to graph fractions or decimals if you don't have to. So whenever you have a fraction involved, what you want to do is choose multiples of the denominator. So when we have 3 over 5, you're talking about choosing something that 5 can divide into evenly. So let me put that stuff back up. So talking about choosing multiples of the denominator. And these are numbers that that denominator can divide into evenly. So what I'm looking at are values like 5, 10, 15, 20, 25, 30, because the 5 can divide into that evenly. If I had 3 over 7, then I would be choosing numbers that 7 can divide into evenly. If it was 11 in my denominator, choose numbers that 11 can divide into evenly. All right. So I chose negative 5, 0, and 5, keeping in the same pattern of how I chose negative 1, 0, 1. And then I plugged in negative 5 into the equation, to the function. So -5 times 3/5. I just went ahead and multiplied across. Recognize that -5 is a fraction. And that gave me 15 over 5. Then 15 over 5 is going to simplify to 3. 3 plus 2 is 5. Let's scroll up a little. So in the next one right here, I plugged in 0. 0 is always a good one. 3/5 times 0 is 0. 0 plus 2 is 2. So when x is 0, y is 2. Then plugging in +5. Same thing, -5, -3 over 5 times 5 is -15 over 5. -15 over 5 gives you -3, and -3 plus 2 is -1. All right. So those are 3 points. -5, 5, 0, 2, 5, -1. And then you graph those 2 points. I mean, those 3 points, excuse me. So -5, 5, you go to the left 5, up 5, and that's right here. 0, 2, I don't go left or right for x, but I go up 2. That's right here. And then for that last point, 5, -1, I go to the right 5, down 1. And that's this point right here. So connect your dots, and that'll be your line. All right, questions before we go to the next thing in this section. All right, so hold on. Yeah, all right. So the next thing you talk about in this section are your functions. And we look at relations first, or relation, just any set of ordered pairs. So relation would be 1, 2, 3, 4, 5, and 6, just like I say, any set of ordered pairs. Your domain, if they mention your domain, just a set of all of your first components of your ordered pairs. So in this case, your x values. So 1, 3, and 5. Your range is the second of all of your second components of your ordered pairs. In this case, 2, 4, and 6. All right, next we're going to list the differences between your domain and range. All right, we're good to scroll up. All right, so your domain, all of your first components, when your range will be your second components. That means your domain will be your X variables, when your range will be your Y variables. Domain is your input, range is your output. Domain is also considered your independent variable, where your range will be your dependent variable. Then your domain will be graphed on your horizontal axis, when your range will be your vertical axis. All right. So next thing they do is tell us the definition of a function. Function is a relation in which the elements from the domain corresponds to exactly one element in the range. Now let me see if they do any exercises that ask you if you have a function or not. Okay. So we won't have to determine if we have a function or not, but they give us the information, I guess, just in case they ask it. I know they're about to notate it in a second. I'll wait for you guys to finish writing that definition. All right, is everybody cool with this before we go to the next page? All right. So here, we're about to close out this section, function notation, wherein y is equal to f of x. Basically, whenever you see y, you can substitute in f of x for it, and it means the exact same thing. And they can interchange y and f of x at will, and expect you to know that that means the same thing. So in here we have y equal to 2x plus 1. Then we have f of x equal to 2x plus 1. And like I said, they both mean the same thing. All right. So then you may say, well, what's the purpose of it? So let's say if we had, trying to look at this right now, we're not looking at that part. Let's say if all we had was find f of 5, or if all you had was f of 5. If you want to know what f of 5 was, then you would know what to do. Basically what that says is that you're going to take 5 and plug it in where you see x. And so that's all it is. It just gives you an opportunity to give give directions by using symbolism versus giving a whole sentence. So, all right, somebody said something in the chat. Okay, yep, you'll be fine. Recordings will come out probably on Friday. Shoot them out Friday. All right, so that means we'll take 5, plug it into the function for x. Yep, not a problem at all. And so that'd be 2 times 5 plus 1. That'd be 10 plus 1, which is 11. So f of 5 is equal to 11. And that also means that my ordered pair will be 5, 11. Remember, x is always what you plug in, y is what you get out, input versus output. I plug in 5, got out 11. And so that ordered pair could be written as 5, 11. So once again, though, this function, these directions of f of 5 can only be established if you have a function f of x already. So you have to define what f of x is. Then they tell you to find, f of 5 or f of 0, or whatever the case may be. All right, questions? Any questions? All right. So let's see, is there anything else with that?
Could you scroll back up, please?
Mm-hmm. Let me know when you finish.
I'm finished.
Okay, sounds good. Let me see one other thing. Okay, got this down here. All right, so we'll come back to that. So let's do the surface area one. It's not really a surface area problem. They pretty much give us a many word problem in which we would have to do what they would be asking of us through function notation. So we have surface area of a cube is given by the function SA, then you have a parentheses, S is equal to 6S squared. So that's SA of S. Really felt like we could have used a better way of determining that function, but that's how they gave it. So I try to give it to you the way they give it, where S is the length of one side of the cube. So it says find the surface area of a cube that has the side length of 10 centimeters. All right. So said our side length is going to be 10 centimeters. I post chapter 9. Yes, I post chapter 9. That should have been last week. Yeah, chapter 9 should have been last week. Yep, just let me know if you don't see it so I can resend them or, something like that. So S, your side is 10 centimeters. So all that means that we would take 10 and plug it into the function that they gave us. And so that's what I did right here. 6 times 10 squared. 10 squared is 100. And 6 times 100 is 600. You got to shoot me that email. Shoot me that email because I'm going to forget when we get out of this classroom. So yeah, shoot me that email to request that and I'll resend it. Yeah. Oh, check Blackboard though. And Blackboard, remember in the announcements I told you I put them in on Blackboard? Check your Blackboard announcements. They should be in there. Should have been the last email. No, because I sent you the email about your due date. So the next to last email or like next to last announcement, it'll be there. Okay. Yep. Check that. If you don't see it in there, that means for some reason I never sent it out at all. And then so I'll shoot that through Blackboard again, or at least it never got sent. All right. So any questions on that? Pretty much all they wanted to do was plug in 10 into that function and then calculate. All right. Then the last one that we'll do for today, because you guys got stuff to, make sure you cover up or knock out as far as what chapter 7, chapter 9. I want to make sure you guys hit that due date. But of course, we can't do nothing when we come in, so we'll stop right here. They give us the function g of 10, g of t is equal to 2t squared minus 3t plus 1. And they want us to evaluate that when t is -2. So that just means we're going to take -2 and plug it into that g function. All right, so that's 2 times -2 squared minus 3 times -2 plus 1. All we do is take -2, plug it in where we saw t. -2 squared is 4. -3 times -2 is a positive 6. So that's why we have a plus 6 right there. 2 times 4 is 8. So we got 8 plus 6 plus 1 will give us 15. So when t is -2, the result will be 15. All right. Questions on anything? All right. So like I said, that's just 10.1. We'll get more into chapter 10 next class. But I'll fall back today, let you guys make sure you guys have ample amount of time to close out chapter 7 and chapter 9 for this 5-week grading. Anything else before we close out today? Send you guys out into the weekend. All right. So that means if you guys are good, I'm good. You guys have a great weekend. Be safe, and I'll see you in next class.
You too.
All right, thanks. Thank you.
Have a good day.
Thanks. You do the same.